Record. I pushed the record button. Let's go to the board. All right, this is from my Tuesday, Thursday class yesterday. You can probably tell what we were talking about. Let me erase everything. So we talked about, I drew 4 compounds. I remember. I'm getting better. I think I'm getting my memories back. There were 4 compounds drawn on the board, and I asked you guys to think about what would be their relationship, mirror image relationship. Mirror image, superimposable, mirror image, non-superimposable, and that kind of stuff. So let's discuss that, and let's take the discussion further. And I want to get close to the end of this chapter, stereochemistry today. Maybe not completely done, but Monday will be done, and I'll start a new chapter. Okay. Nucleophilic substitution is what I think I'll talk about. And I don't want to spend a lot of time on that. I think I'm just going to give you like a very basic overview of what goes on there. After that, we will talk about that. We'll talk about some elimination reactions. Then we'll talk about aromatic molecules. Hexagon, benzene, like cyclohexane with 3 double bonds. We'll talk about that. Then we'll talk about some carbonyl chemistry. That'll pretty much be it. That'll pretty much be it for this semester. All right, so I actually like the way I kind of evolved yesterday teaching stereochemistry with the Tuesday, Thursday class, and I think I'm going to follow that style. So before we do that, let me just give the board a little better wipe. I had some computer problem in the morning. I think it overheated last night. I forced shut it, and this morning I was panicking that it's not booting up. But then eventually, after going through the cycle like 2 times, it worked. I'm recording. Yes, I'm recording. Hi, Caroline. Your name is popping up on my screen. Maybe there was some noise. There was an old song by Neil Diamond. It's very old. It's a very nice song. It has your name, Caroline. Caroline or Carolina? I think Carolina. You can Google afterwards. Don't Google now. Don't Google now. All right. We are the invincible organic chemists. Okay, we are, my black pen is almost dead. Chemate, Monday, Wednesday, Friday, fall 20, and today is 11/6/2020. Okay, talking about stereochemistry, right? Talking about stereochemistry. And let's bring the mirror out. Where is the mirror? Is it in the penthouse or is it in the dungeon down in the basement? Let's get the mirror out. Okay. Here is our mirror. Mirror, mirror, who is the ugliest molecule in the world? No symmetry. I don't think they have that kind of, impressions. Molecules don't care how they look like. We do, humans do. Okay, what did I find a problem yesterday when I was looking for models? The hydrogens today have to be black, whether you like it or not. Historically, our hydrogens have been blue, but I realized that in order for making 2 methane molecules, I need 8 blue sticks, and I don't have 8 blue sticks. I only have 6. And I was getting really mad at my wife for stealing all my models, but then I realized that I'm supposed to share in this world, right? So then we decided that yesterday, hydrogens were going to be black. All right. So this guy, let's draw a black methane. I don't like it that way. I like it this way. I'm going to draw 4 compounds, okay? It might be different from what we did for your homework. I used ABCD today. Let's not use ABCD as groups. Let's use some halogens. I'm going to replace the hydrogens with halogens. The reason I have to use the black ink, the black marker, because even though it's kind of dying, it's pretty light, is because my methanes are going to be black. Okay, so this is, let's say this is molecule A and molecule A prime. We will make models and we will investigate their relationship. Mirror image, yes or no? Superimposable, yes or no? Then we will give them some new definitions under stereochemistry. So that's molecule number 1, okay? One set. The second set, what I'm going to do is I'm going to change, let's put it pretty much the same place. Let's keep everything same except for 1. Let's do the same thing that I did yesterday for Thursday's class. Okay. I haven't actually uploaded some of the videos. I don't know if I uploaded the video and the pictures for your Wednesday class. I think I did. I don't have good memories from last night. It's pretty beat up. I haven't done that for my lab and Thursday's class. Let's make the purple bond as a fluorine. Okay, we will investigate it. Let's change 1 hydrogen at a time. So if we have to name it, it's going to be fluoromethane or methyl fluoride, kind of like our toothpaste ingredients, fluorides, but those are not aromatic organic fluorides. Those are sodium fluoride or calcium fluoride. They're inorganic salts. They're ionic compounds like sodium chloride. So it's sodium fluoride, potassium fluoride, calcium fluoride, different cations and anions. In this case, it's an organic bond. It's a very polar bond because electronegativity of fluorine is much higher than that of carbon. You need to remember that for your final. Fluorine is 4, carbon is 2.5, hydrogen is 2.1. Okay, just making sure that you are not forgetting everything that you learned earlier. Okay, so that's molecule number B. Let's say this is B and B prime. Molecule, and supposedly it's mirror image. Let's draw the 3rd molecule. Let's change 1 more hydrogen. Okay, I'm definitely going to keep the hydrogen in the back intact. I'm not going to mess with it. Let's keep another one there. How about yeah, let's change the one on the left. So this is a fluorine. Fluorine is kind of jutting out from the board. That's a fluorine, that's a fluorine. And let's put, what did I do yesterday? I think I put a bromine in the back. So now this molecule has 2 hydrogens and 2 halogens, 2 different things. So essentially, around the sp3 carbon, this is an sp3 carbon, they're all sp3. Only single bond, sp3, they're kind of tetrahedral. A perfect tetrahedral, little screwed up tetrahedral, more like a tripod. This is little more messed up tetrahedral. Same thing, right? Mirror images. So this here, let's call it, that's A and A prime. Let's put the A and A prime up on the top so that they don't come in the way with the other compounds. Let's say this is A and this is A prime. That's B and B prime. And let's say this is C and C prime. Okay. Now the 4th molecule, obviously, you know what I'm going to do. I'm going to change 1 more hydrogen to another halogen so that the central carbon has 4 different things around itself. Okay, hydrogen, fluorine, chlorine, and bromine. So let's introduce a chlorine. So this molecule down here, the ink is really drying up. Let's keep this dude here. Let's not mess with the hydrogen in the back. There is a reason for me to do that. You will know pretty soon. The fluorine is out. The bromine is in the back. Let's introduce a chlorine. Chlorine is not supposed to be drawn with green color. It sends the wrong message. Chlorine is not fun. You cannot breathe chlorine just because I drew it in green color. I'm using green because it's going to create some good contrast. Okay. So this molecule has 4 different things around itself. This guy has 2 same things and 2 different things. This guy has 4 hydrogens. This guy has 3 hydrogens and a chlorine. So let's call this molecule, this set, D and D prime. Okay. Now, the questions that I'm going to be asking you guys, or as we go through the lecture, is A and A prime, what's the relationship? Are the same, mirror image same or not? B and B prime, C and C prime, D and D prime. Okay, I'm going to drop the pens and make the models. Okay, the models are all messed up because this is the final compound that we have built. So this guy has to go back to the shape of methane. 4 hydrogens. Remember, today it's not a carbon. Don't get confused. Hydrogen, 4 hydrogens, 4 black hydrogens. Okay. This is a no-brainer, so you should be able to answer that question very, very fast. Molecule A. Molecule A. Methane and its mirror image methane. Central carbon, tetrahedral, or what do you call sp3, and 4 hydrogens around it. These are 2 hydrogens, these are 2 hydrogens, these are 2 hydrogens, and these are 2 hydrogens. What is the relationship? If you try to superimpose one on top of the other, do you think they're superimposable? Yes or no? I'm not looking at the chat, I'm not looking at the screen. I'm looking into the camera so that you feel that I'm looking at you. Answer me unmuting yourself. Same or different? Superimposable? Yes or no?
Yes.
This is what it's meant by superimposable. Does it look like it's superimposing? Like all the hydrogens are laying on top of the other? Yes or no? There is no trick question. What you see, you say.
Yes.
Yes. So when you have 2 methanes with 4 identical groups, they're mirror images, because if this methane looks into the mirror, this is what it sees. There is a hydrogen here. That's the mirror image of, there you go. That's the mirror image of that hydrogen. That's the mirror image of that hydrogen. That's the mirror image of that hydrogen. Okay, and that's the mirror image of that hydrogen. The central carbon are mirror images. They look like perfect mirror images. Their relationship is because there is so much symmetry. This is a symmetrical plane, right? That's a symmetrical plane. This is what I did. I tore one of my envelopes. If we use this plane, okay, if we use this plane, the plane that's holding on to that carbon and this carbon, then you can see that it's bifurcating between this CH-CH bond. So the left side and the right side are same. So similarly, if you do that the crazy, experiment on any of this bond, any of the CH planes, okay, if you think about this CH plane, yes, that's a mirror. It's called a mirror plane because it mirrors, like left side of the molecule and the right side of the molecule are mirror images. That means symmetry. Left and right are mirror image. That means my face has symmetry. It's not entirely true, but in a very loose, meaningful way, it's kind of true. If you take these two hydrogens and consider that plane, yes, there is symmetry. So there is tremendous amount of symmetry. So the relationship between molecules A and A prime is that they are mirror images and they're same molecule. They're not different. Okay, so let's write it down. So the relationship between them, this guy and this guy, let's use a different color. Let's use blue and red. They are mirror image and they're superimposable. That means, let's use a different color. This is my problem. I change pens so much. That's probably one of the reasons why I never finish things on time. They're same. Okay, they're same. Let's analyze B and B prime. Let's put a fluorine. Okay. Bye hydrogen. Let me hold it the right way. Where are they? Okay. B, that's B, and that's B prime. B on your left, B prime on your right. One fluorine, 3 hydrogens. This molecule would be named fluoromethane. Fluoromethane, F-L-U-O-R-O. Right after we finish this chapter, we're going to be talking about all kinds of alkyl halides. The reaction will start with alkyl halides. That's one of the reasons I chose all the halogens. Get used to the naming. We'll do some little bit of naming if we have time. Fluoromethane. What do you guys think? There are obviously mirror images. Mirror image, the fluorines, they look like they're mirror images. Their location, hydrogens are mirror image. These two hydrogens, like the tail hydrogens, are mirror image. And the hydrogen that's behind, hiding from you, that they're mirror images, right? Geometrically speaking, if the mirror is right here, okay? Are they superimposable? Yes or no? What do you guys think? If you put the fluorine on the fluorine, central carbon on the central carbon, and one other hydrogen on the one other hydrogen, do you think they will perfectly superimpose? Yes or no? It's not a trick question.
No.
Yes. Louis?
I say yes.
Louis says yes, team says no. Let's fight. Anybody else? I want to hear from somebody else. Cheng-Shi.
No,
I say no, but just the way, depending on the way that you put them together.
Yeah, you put them together. You don't have to try to superimpose this way. You superimpose by lining them up. I'm deliberately not doing it because I want you to imagine you're holding it the right way to superimpose. You don't have to hold it this way. You can say, oh, no, they're not superimposable. Look, but that's not how you put two things together. You try to line them up. I am deliberately not doing it because I want you to imagine the molecules in your head.
Got it.
If I hold them this way, are they superimposable?
Yeah.
What do you guys think? You don't have to, I mean, if I'm comparing, I don't have a second phone. If I'm comparing that the two black sticks, okay, This is how maybe when you hear it from an instructor, this sounds like there is something in between the lines. Okay, if I say, are these black sticks same? They're mirror images. Two sticks with some wedges and whatever shapes built in themselves, right? You can clearly tell that they're identical, right? If I tell you that this is a mirror image, this is a mirror image of that. If I ask you, are they superimposable? Okay, are you going to hold them this way and say, oh, Dr. Maitra, they're not superimposable? Oh, no, they're not superimposable. Okay, they're not superimposable. Is that how you do your testing? You don't do your testing that way. You try to line them up by sticking one next to the other, and then you say, oh yeah, they look pretty much the same. They're superimposable. They're identical compounds. They're mirror image and they're identical. Okay, so if I have something like this, I'm not undermining your intelligence. I'm just saying that sometimes we make things complicated for no reasons. If you have something like this, I don't know what this is. What is this? It's something. Let's say it's water. Two water molecules, oxygen, hydrogen, hydrogen, two lone pairs. If I say these are mirror images of each other, these two hydrogen molecules, and I position them this way, or I position them this way, or I position them this way. And then I ask you, are the water molecules superimposable on each other or not? And then if you try to hold them this way and say, oh, no, they're not superimposable, that's really foolish, right? I'm not condescending. I'm just saying that sometimes how we think, simplify your thoughts. On organic chemistry, just minimalist approach, simplify. That's why I can do it. I'm not a very complex person. Whenever I'm angry or upset or happy, I show. That's been my problem. That's why I didn't survive in the corporate world. You know why? You're smart enough, you're old enough to understand what I'm talking about. I hated the corporate world. I was there for 8 years. I hated it from my gut, especially toward the end. Just lies, games, insecurity, multiple pockets of power. Everybody's trying to go up to the top by suppressing others, jealousy, backstabbing, you name it, fudging data, making up data that you're trying to develop a medicine for metabolic disorder, for high sugar, okay? And eventually, after 10 years of research, it turned out that they were fudging data. They took one line from one experiment that where the standard compound, metmorphin, you might know, metmorphin increases insulin and reduces sugar. That was our standard compound. So when in one study, the metmorphin worked, but the compound that our company was trying to develop, that didn't work. So that was a failed experiment, right? But listen what happened. In another experiment, metmorphin worked. The metmorphin didn't work, but our compound worked. So they are both failed, right? Something went wrong. So they took this line from here and took this line from here and made a new Excel sheet and basically fudged data. And when they were caught, they were saying, oh, really? We are not supposed to do that? I thought it's fine. So when this thing started happening, I said, you know what? I better get the hell out of here. So I ran with my tail in between my legs and actually flew. I could run through the ocean. Keep it simple. Okay. Two water molecules, are they superimposable? What would be your answer? Are you going to check the superimposability by holding it like this? Like, oh no, they're not superimposable. See, they're not superimposable. I'm not mocking you guys. Maybe I'm doing that a little bit, but then so that it's memorable, you don't screw up in the exam. They are superimposable. This is how you do the testing, right? This is how you do the testing. You try to lay out one on top of the other. That's how you do the experiment. So with that, if I
Wouldn't they all be superimposable?
sorry?
Wouldn't they all be superimposable?
Let's not get there yet. Hold your excitement, Jacqueline. Just be patient. Patience is the virtue. Patience is the key to success. That's what Buddha said. Somebody said. I don't know who said. Shakespeare said. Maybe Kennedy said. Okay. Fluoromethane on your left and its mirror image, fluoromethane on your right. tell me now, without me giving you any hints, are they superimposable or not? What do you think? Do your mental moving around the molecule? Yes or no? Superimposable? Yes or no?
Yes.
Yeah.
Yeah, because you line them up, and if they all fall on top of the other, then they're superimposable. The answer is yes. I used my chair yesterday, not the department chair, but this chair, and it was kind of like pretty helpful. So how should we hold it? Yeah, can you guys see it? Kind of see it, okay? So these two molecules, yeah, you guys can see it. Okay, so these two molecules, now it's blocking. It's black. I wish I had a white chair. Yeah, we can solve that problem. This is my lab coat. There you go. See, if there is a will, there is a way. Looking better? Okay. So this molecule, which two are we talking about? B and B prime, right? So you know what? We don't have to have this here right now. So molecule, I know Jacqueline is too excited. She wants to know about all the compounds. So these two guys, B and B prime, they're mirror image, definitely. They're superimposable, definitely. That means they're same. Same compounds. The relationship is the same. Okay, Jacqueline, you need to hold your excitement and just go stepwise. Okay, we can't jump the steps. Let's change one more thing. How did we go? C, we put a bromine, right? Let's put a bromine here. Let's change one more thing. This is really fascinating. I wish I could talk about stereochemistry the entire semester. C and C prime, right? C and C prime. I'm wearing a relatively white shirt. That's your background. Okay. What do you guys think? Superimposable or not? Think about it for 30 seconds. I can hold it for 30 seconds. I promise I won't talk. But you can say I'm ready to answer. Superimposable, yes or no?
No.
Cheng-Shi.
Maybe yes.
Cheng-Shi is like, I don't think he's happy with my first answer. What if I'm trying to trick you? See, now I totally confused you. Just look at the molecule. Don't look at me. Maybe I wish I could just stand with my back on your side. That'll be holding the molecules will take some practice. When I was really bored as a small young child, 7, 8, 9, 10 years old, I used to ride my bicycle. That was my only toy. So I used to do all kinds of funny business with my bicycle. So sometimes I would cross my hands. So I learned how to ride my bicycle with my hands crossed. And it's not easy. Don't try it when you are going fast. Somebody tried to mimic me when we were coming back from school, and we used to have boys' school and girls' school. So, sometimes we used to go very fast in front of the girls' school. And this guy who wanted to show off, he said, "Oh, Shantanu, you can do that? I can do that too." So the moment he swapped his hands, he had the epic crash of that particular year. He fell down and it was really embarrassing. Okay. But I don't know why that story came up. I have no idea. Okay. Fluorobromomethane. That's the real molecule, and that's the mirror image on your right. Superimposable or not? I'm supposed to be silent. Anybody?
Superimposable.
Superimposable, who says that? It's the
Honor.
Connor, you're speaking after a long break. What happened? You had throat pain? Thank you. Okay, one answer is yes. Cheng Shi, Luis, Jacqueline, whoever, Guillermo, you have your cameras on. Who's that? Aaron.
I say yes.
Jacqueline says yes. Okay, let's try to superimpose. I'm going to obviously do some monkey business and annoy you guys. Oh no, look, they're not superimposable. That's foolish, right? Well, you try to lay the red on the red, and oh, I destroyed them. Poor molecules, they're broken. I don't know if molecules fall, can they break? We don't know that answer. I'm really being a monkey right now. I don't know how to do this. I need to go see a psychologist. Okay, there you go. Yes, they're superimposable. Let's not waste our time on this, okay? They're superimposable. They're same compounds. So how do we put them together? Red and that way and this way, right? Yeah. Okay, so these two guys are also, they are also superimposable. Mi, Si, therefore same. Obviously, you have a hunch what's going to happen now. I can guarantee that you have an idea what's going to happen now. Let's put the chlorines. Jacqueline, this is the time for climax. This is the last chapter of the book, last scene of the movie. Oh no. Okay, does it look like D? Yeah, that looks like D. And I just messed up. No, this is wrong. Looks good. Chlorine, bromine, fluorine, and hydrogen in the back. Hydrogen in the back, that guy, the mirror image, fluorine out, chlorine up, and bromine back. Ready? What do you think? You know what I'm asking. They're definitely mirror image. Mirror image, mirror image. The tails look like mirror image. Hydrogen is mirror image. Are they superimposable? Don't tell anyone. Take your time. What time are we at? 8:34. Oh, I want it to be 8:24. Can we turn our clock back? Should we try? Let's try to superimpose two. Let's try the fluorine and the chlorine. Okay, yeah, they're superimposable. See, they're superimposable. Well, not. Let's try to superimpose the black and the hydrogen and the bromine. Okay, we just superimposed the what is this? Bromine and the hydrogen. Oops, the fluorine and the chlorine are screwed up. Let's try another combination. Let's try green and black. Green and black, so chlorine and hydrogen. Oops, bromine and fluorine are, so they're different. When you have four different groups around a sp3 carbon and their mirror images, they're different species. They're different kind of compound. They're same compounds, almost same, right? If you write them down, right? Hold on just a second. No, I'm really being silly here. Okay, there you go. That's the way it has to be. There you go. Okay. Okay, so these two molecules, there is something spooky going on. These two guys, D and D prime, they are definitely mirror image. Okay, they are not superimposable. Okay, they're not superimposable. That means if you cannot superimpose them, that means they are not same. They're different compounds. The different isomers. There you go. Finally, I got the right word. Different, some weird isomer, different isomer. What kind of isomer? Well, what the words that I had on the top, they're stereoisomers. They're different stereoisomers. Stereoisomers. Okay. They're different stereoisomers. So there is something weird about them. But think about the molecules. If you just draw their formula, the formula is very benign. If you just write them down, what would you write? You would write, I'm just going to use one color. You would write, like as if you're seeing it in canvas, black. You're going to write CH, fluorine, bromine, and what? Chlorine, right? So you will write that for D prime. This is going to be your D, and CH, F, Br, Cl, you're going to write the same thing for D prime. So if you just look at the formula, you have no clue what's going on, right? If you just write it down, or if you just write it down this way. Hydrogen, bromine, chlorine, fluorine. Hydrogen, bromine, fluorine, chlorine. And if I say, oh, they're mirror images, then you'll say, oh, yeah, but once you flip it, they're the same. Then you will say, oh, they're same. They're mirror image, and they're superimposable. Because I have drawn it in 2D. That's what the problem is. That's where the problem is. It's flat. It's not flat. This is wrong. This inference, this outcome of our experiment is wrong because this is drawn in 2D. That's the problem. Okay, you need to draw it in 3D, out and in and on the plane and blah, blah, blah. You know how to do that, right? How to draw a tetrahedral carbon. So when the definition is, this is the definition. Again, it didn't break, luckily. Just kidding. The definition is when an sp3 carbon has 4 different groups attached to itself, okay, around that carbon, sp3, not sp2, not sp. sp3 carbon holding on to 4 different groups, then the molecule and its mirror image are different stereoisomers. Let me just write down the whole thing, even though it could be a long sentence. It's not a test of English, I know. Okay. The definition is when or N, I think it's an N, right? sp3s, I don't know. When an sp3 carbon is attached to 4 different atoms or groups, the molecule, the real molecule on the left side of the mirror, the molecule and its mirror image are not superimposable. imposable. That's a long sentence. Okay, they're not superimposable. When an sp3 carbon, that's important. It has to be an sp3 or tetrahedral carbon. When an sp3 carbon like this is attached to 4 different things: hydrogen, chlorine, fluorine, and bromine. Okay, and if you build its model as a mirror image, not as itself, when you build them that way, the two molecules are not same. So some definitions. Okay, when that happens, when this business happens, they're special. These two compounds are kind of special. Okay, that when that property is arising, that the molecules are not same, then we put an asterisk next to that carbon, that special carbon. Okay, and the central carbon is called chiral. Okay, the central, this guy. That's what I'm mentioning by referring to as a central carbon. The central carbon, central sp3 carbon, is called let's write it down with a different color. A chiral carbon, CHIRAL. Chiral carbon or chiral center. This guy, this carbon or this carbon, they're called chiral center. Chiral center or chiral carbon. Okay, there is another word called asymmetry, because having 4 different things, the symmetry of the molecule is pretty much screwed up. Let's pick up one of the compounds and let's see if there is any symmetry. 8:43. We have 7 more minutes. Let's consider this plane. The plane that's the plane that has the fluorine and the bromine, right? If you analyze that plane, well, you have chlorine on your left and hydrogen on your right. That's not a plane of symmetry. Plane of symmetry means, or it's a mirror plane. Mirror plane means it's mirroring the right side with the left side. You got different things on the left side and right side. There is no symmetry along that line. Let's check out another set. Let's check out the hydrogen and the chlorine. Hydrogen and the chlorine are on the same plane, right? So check that mirror plane. Well, it doesn't look like it's working, because you got, what is that? Bromine on the right and fluorine on the left. They're not mirror images. That's also messed up. Let's check this plane. Chlorine and fluorine. Oops. You've got hydrogen on the left and chlorine on the right. Whatever, you know what I'm saying. Doesn't have to be that accurate. Okay, so that means once you put 4 different things around an sp3 carbon, you just completely ruined its symmetry. So I told you about ibuprofen. One of the carbons in ibuprofen has 4 things attached to itself. It's pretty cool. In aspirin, you don't have any carbon. In Tylenol, you don't have any such carbon. In banana oil, I just talked about banana oil. That's why it came to my mind. In my Chem 129A class, there is no such carbon, right? So you don't have to worry about lefty and righty. For ibuprofen, you have to worry about lefty and righty, because there is a carbon that has a hydrogen and a big group and a butyl group and something else attached. yeah, if I have to draw to see like what exactly is going on. Hydrogen and a benzene ring and a butyl chain and something else. Okay. I know the structure, but I can't remember it. So the bottom line is whenever you put four different things around, it's a simple concept. And I think you should carry this concept with you beyond this class. Like you should look at objects and see if it is symmetric or not symmetric, you know? And that's how we started our discussion. You have a cube and you write an O, symmetric, mirror image, superimposable. You write a J and the mirror image will have a reflection of J, not superimposable. And you can keep playing with it. You can do another experiment. You can put different shapes around cubes. You make two white cubes. You can do origami using a white piece of paper. Put like a line on top of it, okay, mirror image, and then put another line somewhere else on another plane, making it mirror images, okay? If there is a cube here and there is a cube here, right? Imagine it's a cube. You put an O, mirror image superimposable. Then you put another O on the top and see if they're superimposable. Then you put a line in the back on both of them, they're superimposable. They're mirror image, and try to see if they're still superimposable. It's a very cool experiment. You will find that in sometimes, even though you have symmetrical objects on the surfaces, on the faces, but the whole molecule is not superimposable. It's a fascinating subject. It's really fascinating. It's probably fascinating for me because I always love geometrical shapes. Okay, how much time do we have? Three minutes. So now the next question is, what are these centers called? What are these molecules called? They are stereoisomers. Is there any specific name for it? So when you have a molecule with a carbon, one carbon, it can be a huge molecule. Everything else is like, doesn't look like the carbons have too many things attached around itself. But there is one carbon that has four different things attached. That makes that entire molecule chiral. We say it's a chiral molecule. I think chiral is Latin or Greek, I don't remember. And it probably has something to do with symmetry. You can Google it later. You can Google the word chiral. What does it mean? Okay. It's probably something to do with symmetry, probably lack of symmetry or something like that. Okay. This whole molecule is chiral, and the relationship between these two molecules, they're called, new word, enantiomer. Let's write it down. The relationship between these two compounds, these molecules, D and D prime are, I'll write down with big letters, enantiomer. Back in India, we used to call them enantiomer. I had to relearn a lot of my pronunciations. Color is written with an U at the end. Probably Chengshi will relate to that, or somebody who has grown up in a different country. Color is C-O-L-O-U-R. Aluminum is not aluminum in India. Aluminum is aluminium, the British spelling and pronunciation. I got made fun of by my graduate school colleagues. Like, Shantanu, what is aluminium? Okay. I still get made fun of because I have some problems with some pronunciations. Like when you have two E's versus an I, it can get into trouble. So I have trouble pronouncing, and I have trouble pronouncing W. I can't pronounce W. Okay, so D and D prime, when you have two molecules with this carbon that has four different things attached to itself, they are called enantiomers. So essentially, left hand and right hand, mirror image, not superimposable, enantiomer. Enantiomers. Enantiomers. Two shoulders, two knees. That's not my knee, that's my elbow. Elbows, knees, feet, kidneys, liver, not liver. Lungs, they're enantiomers, right? Assuming they're same size and same shape. They're not, but let's assume that. So whenever you have two objects, two molecules that are mirror image, but not superimposable, they're called enantiomers. I wish we had time to talk about how to designate the two compounds, Like, how do you know, or how do you communicate with someone by saying that, well, this is this and this is that? You know, what's the next class? Next class is Monday, right? So I'm not going to erase the board. We will just go from here on Monday morning. And what we will do is I will teach you very quickly how to designate, how to label one guy over the other. It's pretty simple, but it's 8:50. I don't want to drag this class any further. Okay. Have a good weekend. I'm going to upload everything as soon as I can. I know that I'm lagging behind, probably not with you guys, but with other classes. It might take me beyond the morning because I have a doctor's appointment, a dentist's appointment, like right now in an hour's time. So have a good weekend. Do some studying. Watch the videos. Don't slack too much. If you slack too much, it may be not good for your health, organic health. And again, if I see like significant improvement in exam 3 and 4 and 5, just don't panic. 3 and final with the 2 more quizzes, you might be happy. Okay, I might ignore some sins from the past. All right, have a great weekend. Take care. I'm not going to change this guy too. I'm going to keep my lab coat on top of that thing. Okay, I need to take a picture. So have a great weekend. Bye, everybody. Bye, Yasmin. Bye, Javier. Take care, guys. Bye.